Hi everyone, this is problem number 8 from section 4.1, and the problem says the population of Lakeview is currently 150,000 people. And part A asks us to write a formula for the population if it grows by 6,000 people per year, and what is the population after 2 years. And part B asks us to write a formula for the population if it grows by 6% per year, and what is the population after 2 years. And so these two problems are, one is linear growth, 6,000 people per year, and one is exponential growth, 6% every year. So for part A, this is linear growth. And so this is like our y equals mx plus b kind of format. And so our slope here is 6,000. It increases by exactly 6,000 people every single year. In practice, it wouldn't be exactly 6,000, but maybe it's approximately 6,000 people per year, but it's steady around that rate of change every single year is the same. And so they want us to know currently 150,000 people. So we can use that as our starting point, our starting time when time equals 0 of our population. So we can say that our population here is P of T. So we'd like to do population for P and T for time is 6,000 times T plus 150,000 as a starting view. Or you could do P of T equals 6T plus 150, where P is in thousands of people. All right, so really pay attention to your units. This one, P, is in number of people, just the regular population size. Okay, so I'll probably use this part because I like my numbers to be smaller. So what happens, what's the population after 2 years? You just plug in 2 for T. So this is 6 times 2 plus 150, which is 150 plus 12, or 162,000 people. And we should always write out a sentence when we're doing a word problem. So after 2 years, with units, right? After 2 years, the population is 162,000. Okay, and then part B, they want us to write a formula if it grows by 6% per year. So 6%, that means our, this is exponential growth. And that means our R value is 0.06. So our B is 1 plus R, which is 1 plus 0.06, or 1.06. Okay, and then we're going to have our initial value is 150,000, and I'm again going to keep that in thousands of people just so my numbers are smaller. So we'll do P of T equals 150 times 1.06 to the T. And again, P is in thousands of people. Okay, and then we still want to know what's the population after 2 years. So we plug in 2. P of 2 equals 150 times 1.06 squared. If you were in a test situation, you would just leave your answer like this. We don't have a calculator, we can't figure it out. I'm going to pull up Wolfram Alpha so we can see what our population value is. So this should be 150 times 1.06 squared. Right, and that's 168.54 thousand people. I think that's what it was. So again, we would write a sentence after 2 years in this exponential model, the population will be 168,540 people. So we can see that it is in fact growing faster. And if you went even a few more years out, you'd see that difference really start to be strikingly different.